Okay, hey everybody, in this video we are going to talk about how to isolate variables. So say you're given a question like x plus y equals z and you're told to solve for x or isolate x. That's what we're going to look at. But before we do that, we do need to take a look at the order of operations and make sure you've got a good understanding of how that works. Some people call it PEMDAS. I call it GEMDAS because the P in PEMDAS stands for parentheses. But sometimes we use brackets, not parentheses, or sometimes it's both. So I use a G for groupings. So groupings, exponents, multiplication or division, addition or subtraction. If you're like, I already, I know PEMDAS, I don't need help with that. You can go ahead and skip to whatever time I put on the screen. But if you'd like a little refresher, stick around. We're going to do a couple of practice problems, and then we'll get on to isolating variables. I swear this is important. So first, let's just do a few practice ones. So let's do 2 plus 1 times 4 divided by 4. So here's a relatively simple expression. 2 plus 1 times 4 divided by 4. We're going to follow GEMDAS. We're going to look for any groupings, so any parentheses or brackets. None. Exponents. None. Any multiplication or division. I do see multiplication that happens to come up before the division, so I'll do that first. 1 times 4 is 4. I will carry down all the appropriate signs and everything else. And now I have 2 plus 4 divided by 4. Let's go back to GEMDAS. Any more multiplication or division? Yes, there is division. 4 divided by 4 is 1. Carry down everything else. Is there any more multiplication or division? Nope. All I have left is just 2 plus 1. So I just have to add those and get 3. So there we go. There is a relatively basic example of GEMDAS. Let's kick it up a little bit. Let's see if I can come up with a problem that uses all of them. Okay, so let's do 2 times. Shouldn't mumble. Let's see. Oh, I need to do it there. Okay. All right. So let's do this one. We're going to do 2 times the difference of 3 and 1 squared plus 4 divided by 2. We are going to follow GEMDAS. The first thing is look for any groupings. And I do see groupings. I see parentheses. So I need to do whatever operation I can in those parentheses. And I have inside here 3 minus 1. I can do that. 3 minus 1 is 2. And I'm going to keep these parentheses. And the reason I'm keeping them is because of this 2 right outside here. Anytime you see a number or a variable bumped up directly next to parentheses with no symbol in between, it means multiplication. We usually don't use the multiplication symbol because it looks an awful lot like an X. Sometimes you'll see a little dot instead. I learned that when I was in school. But whenever possible, we usually, for some reason, avoid using multiplication symbols just to avoid confusion. So if you see, like I said, a number or a variable bumped right up next to parentheses, it does mean multiplication. Okay, back to GEMDAS. So groupings. I do have my parentheses still, but there's no operation that I can do inside there anymore. I already took care of the subtraction and got that too. So I'm done with the G. On to E for exponents. I do have an exponent. This 2 is being raised to the power of 2, or it's being multiplied by itself. And if I do that, 2 times 2, I get 4. Let's carry on. Oh. All right, back to GEMDAS. All the exponents are taken care of, so now it's multiplication or division. First, I do see multiplication. The 2 and the, gosh darn it, the 2 and the 4 are being multiplied. 2 times 4 is 8. Back to GEMDAS. Do I see any more multiplication or division? Yes, I do. I see division right there. 4 divided by 2 is 2. Carry down the rest. Now I only have 2. Once you get down to just 2 numbers, assuming you've taken care of all the exponents and everything else, all you have to do is whatever operations between those 2. So I just have these 2. All the exponents and parentheses are gone. I just have to add them. I don't even have to look at GEMDAS because all I can do is 8 plus 2. That's it. And I get 10. So I just wanted to make sure you had a good foundation for GEMDAS. If you need a little more help with it, I'll link a few things in the description. You can also ask questions if you'd like. But the reason I wanted to make sure you had a good understanding of the order of operations is because when we're trying to isolate variables, we kind of use the order of operations backwards. So instead of GEMDAS, we're going to use SADMEG. I don't think I've ever actually seen this written in a textbook anywhere, but trust me, it's going to work. So let's start off with that simple example I gave at the beginning. X plus y equals z, and we're told to solve for or isolate x. So let's take a look at the x. Is there any, first, according to SADMAG, is there any subtraction or addition happening near that x? There is. There is addition happening here. Now the opposite of addition is subtraction. So that's what I'm going to have to do. I'm going to have to subtract that y. This is pretty abstract because before, when we had numbers, we were able to combine them and get down other numbers, and that's what we're used to when it comes to math. I will admit this is a little abstract because I'm taking y minus y, and like, what the heck does that mean? And to be honest, it doesn't really mean a lot because I don't know what y is supposed to represent. So kind of just kind of go with the flow a little bit. So you'll see what I've done here is I rewrote this expression, but I put in red the operation I'm going to do to help me isolate or solve for x, our required variable. And you'll notice that I have minus y on the left side of the equals and on the right side. You have to do both sides. An equation is like a balanced scale. And if you're going to take something off of one side of a scale, and I'm talking about, this kind of scale. Oh yeah, that's good art right there. Not the bathroom scale. If you take something off of one side of the scale, you have to take it off of the other. Or if you add it in, you have to do it on both sides. Whatever, because you need to keep it balanced. Ironically, I did not draw a balanced scale, but whatever. So we are taking y away from both sides, and what's going to happen here is whatever you're targeting, in this case we're targeting the y, assuming you use the correct operation, it's just going to completely be gone. So we had a plus y, we subtracted it. It's like having a yo-yo and then someone taking your yo-yo away. It's gone. In reality, I would go and get the yo-yo, but that's not the point. Point is, this is what we end up with. Now I can't actually do z minus y because, like we said, we don't know what those represent. So this is as far as I can go. Check to see to make sure that the x is alone. It is. So we have solved for x. This was a pretty small one. Let's go to a little bit of a bigger one. Oh, this is where I'm going to say, if you skip the cool part about GEMDAS, now you can skip to this point. So whatever time index this is. Hi, welcome back. Okay, so let's solve for something else. Let's do ax plus m equals d. This means absolutely nothing, but it'll help us practice. So solve for x, same thing. So first, look at the x, and then look around the x. That sounds silly, but it's what you gotta do. Look for any addition or subtraction near the x. Do you see any addition, subtraction near the x? Or on the, I should say, not necessarily near the x, but on the same side of the equals. Same side of the equation. So do you see any addition or subtraction on the same side that the x is on? Yes, I see addition right here, plus m. So I need to get rid of that m by subtracting it. That's the opposite of addition. Addition, subtraction, opposites. So if I have ax plus m equals d, and I'm subtracting the m, it's going to look like this from both sides. So m minus m is just nothing. Just the ax. And I have a d minus m. Now obviously I'm not done because x is not completely alone, so let's go back to SADMAG. Is there any more addition or subtraction or addition happening on the same side of the equals as the x? Nope, I took care of it all. So then is there any division or multiplication happening? Yes, there is multiplication happening. A and x are being multiplied. So if I want to undo that, I need to do the opposite of multiplying, which is dividing. So I'm going to divide both sides of this by the a. So, like I said, whatever you're targeting is just going to basically disappear. In the first step, we targeted the M, gone from one side. Right now, we're targeting the A, also going to be gone from this side. I'm going to keep this little line here. So I end up with just an X, which is beautiful. What I have left over, oh, I spelled damn. Swear that was an accident. What I have left over is the difference of D and M all divided by A. And that makes no sense. It's kind of gross. I think it's gross. But the point is, X is by itself. We follow the rules of math, and we did it. Oops, that little line's going to irritate me. Woo! All right, I'm not going to circle it. That's the answer right there. Or you could have written it a different way. I treated the D minus M as kind of one entity. You could take the D divided by A and the M divided by A. That's fine too. Both of these are acceptable answers. Of course, if you're doing a homework problem, it tells you what format you need it in. Keep an eye on that. But as far as doing it out by hand like this, both of these mean the same thing. And we have solved for X. All right, I'm going to make up another one. Actually, you know what? I'm going to backtrack a little bit. I'm just making stuff up, but let me use some formulas that you'll actually see probably in your math class, like this one. I equals PRT. This is actually a pretty common one in finance. You'll probably see it if you haven't already. So let us say we were asked to, or we were given a problem and we had to solve for T. So let's take a look at SADMAG. I'm going to put my little, I kind of like this little line here separating the two sides. So look on the side of the T. Do you see any subtraction or addition? Nope. On to multiplication or division. Do you see any multiplication or division? Yes, I do. Now there are no multiplication symbols because those look like X's, and that would look like PX, RX, T, and that'd be confusing. But the letters all bumped up together like this do indicate they're being multiplied. So the P and the R are being multiplied together, but they're also being multiplied by the T. So I do see multiplication. I need to undo that by dividing. So if I want to undo multiplication by PR, I have to divide by PR. Now, PR is what I've targeted, so it's just gone from the side of the T. And this is a pretty good one. I got T by itself already. And I have, on the other side, I divide by PR. So if you're given an equation, I equals PRT, and you got to solve for T, we end up with this. T is equal to I divide by PR. Let's use another equation you might see. That was a finance one. Let's use a trigonometry one. Let's say you have the Pythagorean theorem. A squared plus b squared equals c squared, and you are asked to solve for, let's say, b. Why not? So solve for or isolate b. It's like for 4. So let's follow along with the SADMAG. Sounds so dumb, but hey, it works. So on the side of the b, the thing we need to isolate, do you see any subtraction or addition? Yes, I see addition right there. So I need to undo that. Now this is actually a little counterintuitive because you're looking at this and saying, okay, well if I subtract, I'm going to subtract the b squared, but I don't want to do that. Whatever variable you're solving for, typically you want to leave it where it is. You don't have to, but usually it simplifies things if you leave it alone. So I'm not going to subtract b squared. It's a squared that I have to subtract. This has an invisible positive sign right there. So I do need to subtract a squared. So a squared minus a squared is b squared. C squared. And I've added in, or I've put in that minus a squared on the left, so I need to put it in on the right. A squared minus a squared is just going to cancel. Oops, that should have been a plus, sorry. So they're just going to cancel, and I have b squared equals c squared minus a squared. Now, when you have a plus sign in front of anything, and you have gotten rid of whatever was before that plus sign, you can just drop it. If it's a minus sign, you have to keep it. But plus signs, like I said, for the a squared, this kind of invisible one, we don't usually have them at the very beginning. Actually, we never do. So I did just drop it when I wrote this third line here. So b squared equals c squared minus a squared. I'm doing pretty good. But b is not completely isolated because I got that pesky exponent right there. So just to go back to SADMEG, just to verify any subtraction or addition, no. Any multiplication or division, no. Exponents comes up next, and yes, I do have one. Now, we've been doing the opposites. You always do the opposites. Like if you have addition that you have to undo, you use subtraction. If you have division you have to undo, you do multiplication. Now, the opposite of an exponent is roots or radicals. We're not going to go into too much detail about roots and radicals, but I will say that the opposite of squaring is square rooting. So we're going to use that fact to help us out here. I'm going to square root both sides. What's going to happen is that is going to completely cancel the exponent of the two because they're opposites, leaving me just the b, which is what I wanted. And it's going to be very, very tempting, at least I think it's tempting, to cancel out these exponents as well. It's like, well, I did it over here. Why can't I do it over here? But we cannot cancel these exponents because the c squared and the a squared are separated by subtraction. Subtraction and addition really, really limit what you can and can't do when it comes to things like fractions, or in our case, radicals or square rooting. We're not going to talk too much about that here. If you'd like a video on why that is, let me know. I can either find one or make one. I'm sure there's one out there. But the point is, because of that subtraction, we cannot cancel those squares the same way we did with them for the b. But it doesn't matter because the b has been solved for. Hold on, I need a drink. Sorry, it's water, I swear. All right, let's do one more. Let me see if I can make one that involves all of StatMeg. Let's see. I'm gonna pause this so you don't have to listen to me thinking. Okay, we're gonna look at this monstrosity here that I just came up with. So we have m times the quotient of x and y, all squared, plus z equals f. And let's say we are told to solve for x. Solve for x. So this will be fun. Alright. So let's look at SAGMEG. And again, we're going to look on the side where the x is. Do I see any subtraction or addition? I do. I see addition. So let's undo that. We can undo addition by doing subtraction. So let me write this out. Remember the balance scales. If I'm going to subtract the z from the left scale, I have to subtract it from the right one as well. Actually, I like the dramatic effect of scribbling that out. The plus z and the minus z. It's like fire and ice, fire and water. They just cancel out completely. It's gone. Physics students are going to be like, no, it's not completely gone, or blah, blah, blah. For the sake of this, we're going to say that it's gone. It's good enough. Okay. All right, so back to SADMEG. Any subtraction or addition left on the left side where the x is? And no. Any division or multiplication? Yes. I see both division and multiplication. I first see, what first caught my eye anyways, was this very clear division symbol. X divided by y. So I do notice that. But I also notice that this x divided by y, it's locked inside the parentheses, and it's got that exponent there. It's like double locked. So even though that's there, I have to kind of put a pin in it. I can't do that just yet. Parentheses are kind of like jail cell. You can't get out until you do the time, or in this case, you can't get out until you do the operation. And since I can't do x divided by y, I have to wait it out a little bit. So we're gonna put a pin in that. We'll come back to it and keep going with SADMEG. We're still looking at the division multiplication, and we did see division, but I also do have multiplication here. I have m times this quotient here. So I can undo that by dividing everything by m. So this whole side gets divided by m, and this whole side gets divided by m. And I targeted the m, so it's gone. Let's keep this up. So I've got x divided by y. That's in parentheses. That's squared equals f minus z. Oops, that was lowercase c, but whatever. Okay, so we're here now. So we have x divided by y, that squared equals f minus z over m. Let's go back to the SADMEG there. Do I see any subtraction or addition? No, I took care of that. I do still see that division, but it's still locked. I don't have any more multiplication. So now we're on to exponents. That's the next part in SADMEG, the E. And I do have an exponent. I've got that too. And remember we talked about the opposite of squaring is square rooting. So I'm going to do that to both sides. There we go. Just the whole thing. So squaring and square rooting, total opposites, they cancel right out. So now I have the x divided by y. And if there's nothing in front of your parentheses and there's nothing after it, no exponent, nothing being multiplied, you can now drop the parentheses. They are gone. I no longer have something in front of it being multiplied like that m, and I no longer have something after it like that exponent of 2. So I can finally ditch those. So I have x divided by y equals this. Oh, that looks like a 2. That looks like a 2. Now it looks like a z for sure. Okay, we're almost there. Bear with me. We are so close. Now, remember, we put a pin in that x divided by y because it was locked. It was locked by that exponent. It was locked by the parentheses. Those are gone now, so we can take care of it. We have x divided by y. The opposite of division is multiplication. I don't know if we've done this yet. I will use the multiplication symbol here, but I'm going to use it tiny. Normally, we won't use it, like I said, because it looks like an x, and that can get confusing. So if I multiply both sides by y, dividing by y and multiplying by y cancels out completely. And I get just that beautiful x that I wanted. Now it's by itself. Now I have this times y at the end here. I'm actually going to switch it up, put it in the front, right here. And the reason I'm doing that is because the times y is not inside the radical. It's not, I'm not multiplying the f and the z and the m by the y. I'm multiplying this whole thing, the whole radical by y. And having it afterwards, it may look like it's inside the radical, but it's not. And that's why I'm going to put it in front. And again, I don't want to use the multiplication symbol if I can avoid it. And so whether you have a letter or a number bumped up against parentheses, or in this case, a radical, it indicates multiplication. So this would be an acceptable way to write the answer. It's the most straightforward, simple way to do it. So essentially, if you are trying to isolate a variable, make sure you have a good understanding of PEMDAS and use it backwards to help you undo all of the things that are happening on the same side as the variable you're trying to solve for. Hopefully this video was helpful. Please leave a comment if you have any questions or you'd like to see more videos like this, and I wish you the best of luck.